Hi, I'm Karinna Martin. This summer, I worked with Dr. Liu at Pitt and Katie Shanks at the University of Exeter to research anti-reflective options for solar panel glass. Solar energy is a clean and renewable source of energy that is an integral part of the global effort to decrease the use of fossil fuels. Usage of solar panels, or modules, for energy generation continues to increase, and with that, there is great interest in increasing the efficiency of panels, as they only convert about 15 to 22% of sunlight. Solar modules contain a fragile solar cell covered by a layer of glass. The glass protects the solar cell from dirt, water, and any other environmental factors it may come into contact with. One barrier to improving solar module efficiency is the amount of sunlight reflecting off of the protective glass layer. Even at optimal angles, some sunlight is still diverted by the glass. This means less light reaches the solar cell to be converted to electricity. This is even higher at suboptimal mounting angles, which are often seen in both residential and commercial applications. My work this summer was on anti-reflective glass for solar modules. We studied normal or bare glass, glass with a thin film of anti-reflective coating, and graded index of refraction or GRIN glass. This graph shows the reflection off of each type of glass versus the incidence angle, and it demonstrates that the GRIN exhibits less reflection than the other two types. We wanted to see what benefits these types of AR glass would provide for fixed solar modules for different locations around the world. Simulations were run in a software that allows the user to define the system parameters, such as the orientation of the module, the type of module, the size of the array, and the glass reflectance profile. The simulations take into consideration the movement of the sun through the sky, as well as climate in places like Pittsburgh, such as cloudy days where there would be less sunlight. The results of these simulations indicate that anti-reflective glass improves energy output at optimal angles, but has a much greater impact at suboptimal angles. In Pittsburgh, you want to mount your solar panel due south, tilted at about 35 degrees. At this angle, you should generate about 189 kilowatt hours per meter squared of energy per year. A typical U.S. household uses about 10,000 kilowatt hours per year, so about 53 square meters of solar panels would provide enough power for a household. The amount of energy generated can be enhanced by using a thin film anti-reflective coating, which increases the annual energy output by about 8%. GRIN structures increase the amount of power generated by 10%. The GRIN glass demonstrates this greater increase at all locations that have been simulated, which has significant implications for its application in solar modules. Thank you for listening.